Okay, welcome back to part 2 of the key to the practice exam. So we're going to start in on question number 5. So question number 5 is all about profit, cost, revenue, marginal things, and so on and so forth. So gun company A will rent a minigun to anyone over 18 years of age for $5,500 per minute. When firing, the ammunition for the minigun, I should say minigun, not mingun, minigun, costs the company $3,000 per minute. Okay, so we're supposed to write down the formula for the costs, write down the formula for revenue, write down the formula for the profit, and so on and so forth. So let's start with the costs. Well, this is pretty simple. We can just read it from the problem. When firing, the ammunition for the minigun costs the company $3,000 per minute. So C of T, we're also supposed to assume here that they already own the minigun. Okay, so we don't need to factor in the price of actually buying the gun. It's just going to be some function of the amount of time that the gun is fired for. So if it's $3,000 per minute, C of T is going to be 3,000 T. Pretty standard. So if I fire the gun for 6 minutes, I'm just going to plug in 6 for T and then multiply it out. Okay, write down the formula for company A's revenue. Remember, the definition of revenue is how much money is coming in before you factor in your costs. Okay, so revenue is just how much money did we charge the person for the rental. Okay, so again, we can read this directly from the problem. It says it will rent a minigun to anyone over 18 for $5,500 per minute. That means that my revenue here is going to be 5,500 T. Now, we want to write down a formula for the company A's profit pi of T. Remember here, pi is not referring to the transcendental number, which goes on and on forever in a decimal like 3.14159 ... We're using pi here as a letter. The reason we're not using P for profit is we already used the letter P for another financial term, namely price. So P is already used up, so we have to use some other letter. For some reason, it was decided many years ago that pi was the letter that we would use. So profit pi of T is equal to the revenue, in other words, how much money I brought in, minus my costs. How much money am I spending? And hopefully, the amount of revenue I'm making is higher than the amount of costs that I'm making. Otherwise, my profit will be negative, meaning that I'm losing money. So we're just going to go ahead and plug in these formulas. We're going to get 5,500 T minus 3,000 T equals 2,500 T. So the company's making $2,500 per minute off of the person who's renting it. Okay, find company A's marginal cost, marginal revenue, and marginal profit. Okay, remember, when we hear marginal, what we should think is slope. Okay, the marginal cost is the slope of the cost function. The marginal revenue is the slope of the revenue function. The marginal profit is the slope of the profit function. You will recognize, hopefully, that all three of these functions are linear functions. Okay, 3,000 T, that's the slope of a line which passes through the origin, or that's the equation of a line, that passes through the origin with slope 3,000. Okay, so marginal cost is 3,000 per minute. In other words, you could write it as $3,000 per minute. Marginal revenue is $5,500 per minute. Marginal profit is $2,500 per minute. All right. Assuming that a buck-wild teenager rents the gun for 5 minutes and holds down the trigger for the entire time, how much money does Company A make? Well, we know that the gun costs $3,000 per minute to fire. If the teenager fires for the entire 5 minutes, then the cost incurred is going to be 3,000 times $5 or 5 minutes. And the revenue is going to be the amount of time that this person rented the minigun for, multiplied by 5,500. So we can just go ahead and plug into our profit function, really. We can just write pi of 5 is going to be equal to 2,500 times 5, which gets you $12,500. So that is how much money Company A makes. Last part of this problem is a little bit more abstract. They say Company B earns profit according to this function. Okay, so here we've got pi of t equals 6,000t, so their profit function is significantly larger than the profit function of Company A. They're making much more money. The question is, if we know the profit function, is it possible to find out Company B's marginal cost from the information we know? Well, we know that the marginal cost marginal profit, is 6,000 T. Well, let's see, I guess we should assume that they're firing the same minigun and that the ammunition cost Company B the same amount of money. So this question could have been worded better. Well, if you were doing this problem at home, you could say that marginal cost is the same for both companies, namely 3,000. This should have been $6,000 per minute. $3,000 per minute. Meaning that pi of t for this function is equal to 6,000 t is equal to r of t minus 3,000 t. If we add 3,000 t over to the other side, we find r of t is going to be equal to 9,000 t, which tells us that the marginal revenue is $9,000 per minute. So the answer is yes, although the question was worded in kind of a funny way. So if I wanted to explain my answer in words, I guess I would say, yes, we can find it by subtracting the marginal cost from the marginal profit. Also, marginal cost for company B is the same as for company A. So that's how I would write it in a sentence. Okay, let me move this stuff out of the way. Put up here. All right, question number 6. Supposed to explain in words what it means for y to be inversely proportional to x, and write down a formula which describes the relationship between y, x, and the constant of proportionality, k. So first of all, I'm going to start with the second part of the problem. I know that y is equal to k over x. That's what it means for y to be inversely proportional to x. Now, if I were to explain in words what this means, is that if y is equal to the value of this fraction, if x is getting larger, then the denominator of my fraction is getting larger. A fraction which has a larger denominator is a smaller number. So I guess what I would say to explain this in words is, as x increases, y decreases since we divide the constant of proportionality by x. So bigger denominator means smaller number. Okay, so that's pretty much that part of this problem. The next part, they say, the weekly average number of Tinder matches, T, that Kelly gets is inversely proportional to the square of the number of words, W, in her bio, with constant of proportionality, K, equals to 400. How many words would Kelly need to write in her bio to secure an average of exactly 2 matches per week? So let's start by writing T is equal to, we know that the constant of proportionality is 400, so 400 goes on top. And on the bottom, I'm not going to put W because the problem says T is inversely proportional to the square of the number of words, W. So what's going to go in the denominator here is going to be not W, but W squared. Okay. So we want to know how many words Kelly should write in order to secure an average of exactly 2 matches per week. So we'll put 2 on the left-hand side equals 400 over W squared. And we want to solve this. So we're going to multiply both sides by w squared. We'll have 2w squared equals 400. And we'll have w squared equals 200. So w equals to the square root of 200, which, if we type into our calculator, square root 200, we get 14.14 something something something. So again, man, there's a problem with this problem too. Shouldn't have said exactly 2. It should have said at least 2. My apologies. At least 2 matches per week. And here's where we have to do a little bit of thinking. We know that we can't write 14.14 words in the Tinder bio. So we know we should truncate. We should either write 14 words or we should write 15 words. Okay? Now the trick is, if I take 400 over 15 squared, should I do this or 400 over 14 squared? And it's not going to be what you may be used to seeing. Typically, we just cut off the decimal and increase by 1 and say, call it at 15. However, since the relationship between t and w squared is inversely proportional, you're going to see if you do this, you're going to get 400 over 225, something like 1.77 repeating. Whereas if we do this, 96, we get 2.04 something something something. So, in Kelly's case, the less words that she writes in her Tinder bio, the more matches that she gets. So Kelly should write no more than 14 words in her bio. Okay, so that's how we do that problem. Again, my apologies for this problem not being quite right. So you're just going to have to imagine that I had put this at least 2 matches per week. All right. Question number 7 has to do with polynomials. We have to write down some examples of things that are polynomials, things that aren't, some quadratics, and we're going to have to solve a quadratic polynomial for the roots. So one example of a polynomial could be, I don't know, f of x equals x cubed plus 37. That could be an example. Here's another one. How about g of x equals x to the power 100? How about h of x equals negative 10 x to the 4th plus x cubed minus x squared plus 2x minus 3. That could be a polynomial. Remember, polynomials are sums of powers of x where the powers are non-negative integers. Okay, integer means whole number. Non-negative means greater than or equal to 0. So those are some examples of different polynomials. Now we're asked to write down one example of an equation which is not a polynomial. I'll give you a couple examples. How about f of x equals sine of x? That could be not a polynomial. Or f of x equals 1 over x. We'll do g. Or h of x equals x to the power pi. Or k of x equals x to the 0.37 plus 2x plus 1. This is not a polynomial. H and k are not polynomials because the power of x, in both cases, is not an integer. Why is g not a polynomial? G is not a polynomial because it's x to the power -1. -1 is not a non-negative integer. It is a negative integer. So that fails it because it's not non-negative. F of x equals sine of x is a trigonometric function, so it's certainly not a polynomial. Okay, now we want to write down two different examples of quadratic polynomials. Okay, well, quadratic just means highest power of x is 2. So we could have one like x squared plus 2x plus 1. That's a quadratic. Another one could be, let's make this one kooky, pi x squared minus 2.1x plus, we'll get really kooky, plus e. This is also a quadratic polynomial, okay? There's nothing wrong with what we've written here. We have one power of x is 2, the other power of x is 1, the other power of x, you can't see it, but it's 0. What might be tripping you up here is the fact that we have pi and e here. But that's okay, pi and e are just constants. They're being multiplied by these powers of x, but they're not powers themselves. Okay? So it doesn't matter that these numbers are not non-negative integers, because we only care about the powers being non-negative integers. Okay, so now lastly we have to solve for the roots of one of the quadratics we wrote in C using the method of our choosing. So I'm going to choose this easy one. I'm not going to bother trying to find out the roots of this nasty polynomial. So what do I have to do? Roots means f of x equals 0. Okay, so I take x squared plus 2x plus 1 equals 0. Now I can solve this one of two ways. I can factor it, or I can use the quadratic formula. We'll do it both ways real quick. If I were to factor this, it factors as x plus 1 times x plus 1 equals 0. This means that x plus 1 is equal to 0 implies that x equals -1. Okay? So x equals -1. That's what we call a double root. Now if I were to say, use the quadratic formula, which if you don't remember, it's -b plus or minus the square root of b squared minus 4ac, all divided by 2a. First thing I need to remember is that a here is just 1, b here is 2, and c here is 1. So I get negative 2 plus or minus the square root of b squared, well that's 4, minus 4 times 1 times 1, that's 4, divided by 2 times a, well 2 times a is just 2. So I get negative 2 over 2 plus or minus 0, meaning that x equals negative 1 is my only root in this case. Okay, so that's how we do that part. That's all for today.